So we're going to look at only association rules from chapter 14. So we're not going to cover collaborative filtering. So we're going to look at two examples like in the textbook. So we'll look at the uh, tiny example with only 10 transactions for phone faceplates, and then we will look at the similar book purchases example. So first is faceplate, and the faceplate file has the 10 transactions in this fashion. So we have a binary uh, matrix with ones representing the transaction included that particular product and zero representing not uh, in the transaction. That particular product was not purchased. Okay, so let's start with setting the path to the default folder. Okay, and we need the library A rules, association rules. So that's what that is. So make sure that that is installed and you run that library. Okay, and now we're going to read in the data and we'll call the data fp.df. Okay, fp for faceplates. Read CSV faceplate, I believe. Faceplate CSV. Okay. So now let's look at the data. So we have the transaction number and then the different colors and whether a particular transaction included that color or not. Okay, for A rules to work, we need just the products matrix. Okay, we shouldn't include the transactions. Just one column for each of the product, one column for each product, and each row consisting of zeros and ones. Okay, zero if the product was not part of the transaction, one indicating that it was. Okay, so we need to get rid of this column and then convert the rest from data frame into a matrix. So we'll do both of them at the same time. So remove first column and convert to matrix. So we call this fp.mat for matrix. Okay, so as matrix will convert the object specified here into a matrix. So we do fp.df. Okay, and we want all the rows and all the columns except the first one. So -1 will do that trick for us. So if you run this, then you have fp.mat and you see the first column is gone, and here we have matrix. So if you want to check whether it is matrix or not, we can do class fp.mat and you run that and it gives you what class the object is, and you see it is a matrix. Okay. Next step is to convert the binary incidence matrix, okay, which is what we have here at fp.mat. So this is our binary incidence matrix. Okay. And we want to convert that into transactions database that can be used to develop the association rules. And we do that using the as function, as, which is part of the A rules library. So we'll call this fp.trans. Okay, as, okay, so now we give the matrix first. The first um, parameter is the incidence matrix as a matrix object, and then we specify class as transactions. Class equal to transactions. Okay, so this is going to generate a list for us. Okay, so here, okay, so it generates the transactions matrix in a form that can be used by the A rules uh, library. So we can now use the inspect function to take a look at what's inside FP trans. So it gives you, okay, each row of the incidence matrix is converted into this form. Okay, so the items, transactions of the items. Okay. Now we can also do using this fp.trans, we can plot item frequency plot. So if you do fp.trans, okay, so now that's going to create a bar chart of the frequencies of each product. Okay, so the incidence frequency. Okay, and it is plotted with the y-axis being relative frequency. Okay. The next step is to generate rules, and there are several parameters that we can set. So let's save this in FP rules. Okay, and the function used is a priori. Okay, and the transactions object is the input. Okay, and then we can set the parameters, and the parameters must be included as a list. So we say list, and then we can specify the parameters. So SUPP is the parameter that we need to set for a minimum level of support, okay, for the rules to be developed. So to specify, so we want a minimum support of 0.2, and then we can say we want confidence of at least 0.5. Then we can set up minimum number of items, okay, which is by default is 1, but if you want to set a higher number, you can set that with min-len. And then you want maximum, okay, usually you don't want maximum to be to be more than the default, but you can set it to a different value if you like. And then you say what you want the a priori to generate for you, and that is called target. And for association rules problem, we want the target to be rules. Okay. Okay. Now if you really want only the frequent item sets or maximally frequent item sets and so on, and you can specify that. But what we want is rules. So if you run that, okay, so now we have the FP rules. Okay, now if you do FP rules and run that, and you would see there are 18 rules. If you want to look at what they are, then you can say inspect, right? Inspect FP rules. And if you do that, then all the rules will be printed. So there are 18 of them, all 18 of them are printed. If you want the rules to be printed in some order, say for example, if you want these rules to be in descending order of lift, so the maximum lift to be at the top. Okay, inspect FP rules, right? And you want um, well, inspect, and if you want it sorted, so you need to do sort FP rules, right? And then say by equal to lift. So now first the FP rules will be sorted by lift, okay, and then inspect will give you the list in full. On the other hand, if you suppose if you have hundreds or even thousands of rules and you want to just look at the top few, then we can do that by saying inspect. Okay, so what you need to do then, inspect, okay, then you can say head. Head will by default print only the top 6. So now you get the top 6 rules, okay, and sorted by lift. Now if you want to look at the list in some combination of minimum level of confidence and a minimum level of lift and so on, we can let's first convert this into a table. So FP rules dot TBL, okay, and we do inspect FP rules. Okay, so now those rules will be captured in this table. Okay, so once that is captured, then we can say FP rules, okay, FP rules table, okay, and we want only certain columns, okay, that satisfy a rule, right? I mean satisfy minimum levels of support or lift or confidence. Suppose we want at least 40% support and at least 60% confidence. Okay, so then we want the rows, so we do FP rules table, okay, support, right? And you want that support to be at least say 0.4. Okay, now you want a compound condition, so you want that and, okay, FP rules dot table, right, say confidence, right, greater than or equal to say 0.6. So that's the condition. So all rows that satisfy that support greater than or equal to 0.4 and confidence greater than or equal to 0.6, and then we want all the columns, so we put a comma and leave the rest blank. So now if you click OK, so you see all the rows with support of at least 0.4 and confidence of at least 0.6. Okay. Now if you want, instead of both, okay, either one must be true, then it is the OR operator. So OR operator is that, and if you run that, then you get all the rows that satisfy either the first condition or the second condition. Okay. Now let's look at a different target. Okay, suppose we want the frequent. Okay, so let's call this frec set, right? So everything is same except that in the rules we want to specify frequent item set. Frequent item set. Okay, so if you run that, then you see there are a set of 13 items. Now if you inspect that, so you get all the item sets for the parameters that we have listed. Okay. But for association rules, we don't want, we can skip this part. We can just go straight to rules, and then you'll have everything that you need there, and that's it. And if you want a certain level of